grey matter. Just want to take a couple of seconds just to let you know a little bit about us if you've not bumped into us before, and then we'll pass over to the team. Grey matter, we've been an IT supplier and services company for 35 years, and alongside traditional licensing for all the key vendors, we have a special focus on cloud, DevOps, big data, AI, etc. And it's great with our relationship and partnership with MapR that a lot of those areas are covered off. And we're really looking forward this afternoon as we've got Antje Bart and Tony Young from MapR joining us on the webinar. We want this session to be as really useful for you as possible. So alongside the elements that have been prepared by the team, please do feel free to post any questions that you might have that you want us to answer. Where we can answer those live on the webinar, we'll certainly do so at the end of the call. And for anything else that's either too big a conversation or anything that perhaps is obviously specific to yourselves where you don't want to go into anything without perhaps NDAs or anything in place, we can certainly take that offline and engage with you post the call. So do pop questions down there, and we really hope you have a fantastic webinar. So without further ado, I will pass over to Antje and she'll kick us off.
Yes, thank you very much, Mark. So also a very warm welcome from my side. Antje Bart. I'm working as a solution architect at MapR in our partner team here in Europe. So happy to present today a little bit more on containers and Kubernetes without limits. So in today's session, we'll actually learn how a modern data platform can help to support stateful applications in large containerized environments. That means how you can actually handle persistent data, not just in your local data centers, but also across multiple data centers, geographic locations, or even across different deployments, whether it's on-site, on-premise, or even in cloud environments. So in short, we'll show you how actually you can achieve something like Kubernetes for data. So just to start a little bit on the terminology for those of you who might not be familiar with virtual machines and container technologies, especially in much detail. So I guess pretty much everyone nowadays heard of virtual machines. So basically, when you think of the concept, they are like computers in a box. In contrast, containers are more like applications in a box. And if we look what that means kind of in conceptual view, in a virtualized environment, you have a host which has hardware, obviously, providing the resources, compute and memory, etc. You have the operating system of the host, and you have a hypervisor technology that then supports and runs the virtual machines, which itself consists of an operating system, the guest OS, the libraries, and the applications. So you can see the stack is pretty much a lot of components playing together here. In contrast, why container technologies have become so popular over the recent years is its simplicity in the stack. So you still obviously need a hardware somewhere providing the resources, you have an operating system, but then you're basically saving that hypervisor layer and have the containers that still separate the application and the libraries from each other, but they're still running on a shared OS kernel. So that just simplifies the whole stack, and it's much more lightweight, especially in environments where you need kind of an agile release cycle and want to be quickly in deploying containers and redeploying somewhere else. Another popular comparison between virtual machines and containers is that pets versus cattle comparison. So the pets would actually be your virtual machines, whereas cattle is more like the new container technologies, popular ones around Docker, and then, as we're going to present later, Kubernetes as an orchestration platform. So what does this comparison mean? So obviously the pets, your virtual machines are long-lived, you give them names, you care for them. So whenever there's something wrong on your virtual machine, you tend to troubleshoot, you look for the root cause, and you want to fix it. In contrast with container technologies, they're ephemeral, you brand them with numbers like cattle, and yeah, we know that's expensive. So when the containers actually have a problem, you don't spend hours and hours in troubleshooting and looking for the root cause. You basically just shut the containers down and start a new container. And that's pretty much why this whole environment is so flexible. So in short, containers are popular because they're really lightweight. They're stateless in many cases, so that's especially an important point in today's discussion, because we nowadays have use cases where we also want to run stateful applications containerized. But in principle, they are stateless, they're portable, they're targeting for developing applications. So this is really where they have the core use cases. They're moving into production, and I think many of you might have already some container technologies in production, or at least looking to deploy them. And for sure, Docker made them popular over the last years. And not to forget, it added a lot of new words and terminology for us to learn. But containers have a problem. And if we look at a study, and this is coming from the Cloud Native Computing Foundation, that is actually home of many of the cloud native technologies and container projects, they do annual surveys of their community members and ask for different challenges in deploying technology. So the recent one from this summer actually revealed that there's like two sets of challenges. One set is around cultural changes in development teams, the complexity in general of new technology, lack of training, etc. And this is for sure something everyone needs to address and find ways to get trained and skilled people. But then the second set is more technology focused. There the respondents mentioned security, monitoring, storage, and networking. Because in containerized environments, there's a whole lot of those challenges you just have to adapt to the new technology stack, which you might have already solved in a virtualized environment, but then you have to adopt all your strategies, tools, etc. to this containerized world. So just for example, some things that Docker as a container engine can't really do. It can't monitor running containers. It can't handle dead containers. Also, when you're thinking of moving containers to another environment to utilization improvements, this is nothing that Docker itself can handle. Similar to auto-scaling container instances to handle load, etc. Networking, port mapping topics. So for those reasons, you can't really move to that kettle environment until you have an environment to support it and to handle the problem of container state. So let's have a look at the first one. How can we really support the kettle? How can we set up such an environment that helps us with those challenges mentioned? And this is exactly where Kubernetes comes into play. So Kubernetes has become pretty popular over the recent month, and I would say probably 1-2 years. It's actually a successor of a Google project called Borg. And Google, obviously, they had already developed those technologies in-house to manage their huge data centers and application deployments internally. And they were using those technologies, and then they decided to open source it. And you can still read the papers here from 2015, which is pretty interesting if you're interested in learning more about the history of where is Kubernetes actually coming from. And after Google open sourced their software, it found its new home at the Cloud Native Computing Foundation. So if you're curious about learning more around Kubernetes, this is the place to go. You find all the information, documentation, demos, etc., interesting use cases. So this is the place to go. And this is where Kubernetes is nowadays also maintained with a huge group of community members that back it up. So what is Kubernetes? Kubernetes is basically an API and agents. And the API provides the containers with all those functionalities that we just discussed that are needed to kind of orchestrate containers, which is scheduling, configuration, helping to solve the networking issues, and also how to tackle the storage in that environment. And then the Kubernetes runtime manages the containers on your hosts. So if we have a look at it more from a visual perspective, you have this magical view of Kubernetes running in your data centers or in the cloud. You deploy an application against the API that I just mentioned, and Kubernetes basically handles the application deployment and starts the container basically somewhere. And then you're fire up another YAML file, and this is how you basically deploy all the applications and components within Kubernetes. You fire up YAML files against the API. So in case you instantiate another application, for example, application 3, again, Kubernetes takes the description and then starts the container again somewhere. So you can define a little bit around where it deploys, but basically you don't care about the individual host anymore. And then as you end up with having a couple of applications running or containers running, Kubernetes provides also the means to handle the DNS between containers, so the containers can really find each other really super fast and easily. So what does that mean? So in this example, you notice that we don't actually care about which machines the applications run on at all. So you don't have to name them anymore after the Hobbit. You just can treat them like cattle, because Kubernetes basically takes care and looks on your application definition, where you can specify how much resources the application needs or the container needs, and then checks the environment and decides and chooses a host that can provide enough resources for the container to run. So this is all handled by Kubernetes now. This actually frees us from those tasks to really put a lot of effort in maintaining and watching over the hosts. So Kubernetes is obviously not the only tool or orchestration software you can use. There are a couple of more in the market, and you probably heard of Docker, Swarm before, or Mesos, and many others. But again, looking at the survey results from that Cloud Native Computing survey from summer, clearly see here on the left that many of the community members, the majority really uses Kubernetes in their container orchestration environment. So clearly, as we say, it won the race in the orchestration platforms. And this is partly due, I would say, back to the large community supporting it, including many of Google developers of giving the root where it's coming from. So yeah, Kubernetes is nowadays, I think, the most popular platform. And hence, this is also the focus of this presentation today, and how we at MapR integrate with containers and with Kubernetes. So I just showed you a high-level overview of Kubernetes and how it can help. If you look at how it can solve the individual topics like the monitoring of the containers or logging, connecting different applications with a service mesh, helping in the network environment, helping in storage, security, etc. Kubernetes also provides this open pluggable framework. So if you go to the website, you can see that there's a ton of projects actually, and those here on the slide are the most popular ones in the individual areas of their expertise. So you are free to pick and choose whatever you find best suitable for your environment, tackling and handling the individual topics here, whether it's networking, security, logging, etc. And as I said, this is just a small subset. The CNCF provides a huge landscape map. I put in the links here for you. So you can really have a look at it, how many projects are part of that ecosystem nowadays, and it's just growing and growing almost week by week. So it's really a strong community and helps everyone collaboratively to embrace container technologies and the orchestration of those. So that's all nice, but we still have a problem, which we haven't talked about, and this is state. So what does state mean? You can refer to it as state or also where to persist data. So when container technologies came up and everyone was talking about, we talked about having those stateless containers that just start, do a job, and then disappear again. The reason why is because it's quite a challenge in handle state in containers, because you suddenly have to care where to store the state information or the data. And if you just restart a container, you're at risk to lose the state, obviously. And also, if you need to replicate those information across to another deployment, it just makes the services really complex, and it kind of is against that concept of having loosely coupled microservices that don't need to pass information. Again, also application developers, they normally don't care too much because they're really not system developers, and they shouldn't. So this state information or where to store data is actually something that is not pretty well handled in containers in the early phase, and it still needs to be looked at. You need a concept basically to set this up so you're good to go with all the containers and can still make sure that you have all the important data somewhere persisted, so that you're not only using containers for stateless, but also you can use it to embrace stateful applications, like if you're thinking of deploying maybe databases in a container environment. So if we look at it again from this conceptual view, you have your Kubernetes environment, you have a couple of applications running there containerized. And what happens normally is the applications can call each other via RPC calls, that's fine. But the reality is that even if it's not a database, many of the applications, they need to work with data. So for example, they need to read some file maybe as an input. They might want to pass on some information to another set of applications or microservices to keep on the work. Or you might even want to store, for example, log files of the application, just in case something you need to troubleshoot later or you want to run some analytics on. So you obviously want to have a way to keep those log files even if the container is destroyed and gone. So basically what you need is multiple forms of persistence. So you need to persist like files, for example, real-time streams, etc., maybe even tables where applications are based on. And this comes back to the point, you need to have a data platform somewhere where you can persist the information and make it available for those containerized environments to do their job. So when we look at this data platform, what characteristics does it need to have? So what would be really nice is to have a global namespace concept across a Kubernetes cluster. That means that you can easily find the data set independent of which host the container is running in. And it would be even really nice if you could have that concept between different Kubernetes clusters. For example, if you're having a second data center location for DR purposes, or you want to have parts of the deployment maybe in a cloud environment, plus the on-premise data center. You need a platform that can persist all the different kind of data primitives like files, streams, tables. The data platform needs to scale very easily. So as the environment grows, you can also grow the data platform. And also access control and security are important nowadays. So you want to make sure that you can have fine-grained controls over who has access and permissions to the data stored in the platform. To summarize this part, the data platform needs to be like Kubernetes, giving you all the agility and making the data independent from the underlying infrastructure and serving the application needs. So it's Kubernetes for data. And this is exactly where we at MapR can help you with. And I'm just going to introduce to you now a little bit of the concepts of our MapR data platform. So what we offer is a software that can help you to store all kinds of data. So like a distributed file system. We can take files, we can save objects, tables, real-time streams, and we can make this independent of the underlying infrastructure. So you can deploy parts of the platform in data centers, in cloud, at edge locations where you might have just a small subset of hardware resources available, and obviously also on Kubernetes environments. We then expose many of well-known APIs like NFS, POSIX, REST, F3, HBase, etc., and others to the applications that sit on top or to the containers, so that you have the freedom of using your tools of choice to access the data. And this is also how we integrate into the container environment, which is having a little piece of integration into that platform, which I'll show you in a bit, and making it possible that containers can store the information in the platform with all the controls, obviously, that you need to also separate, for example, the use cases if you also want to use the platform for traditional analytics or enterprise applications apart from the container environments. So looking at the points I mentioned earlier, what you would look like for in a data platform. We're coming from a big data background, so the platform is easy to scale. You can start small and we grow horizontally with the amount of data and containers, etc. We distribute the data across the whole cluster environment, and we also offer you a global namespace, which I'll touch on the next slide. So we can really give the applications and the containers access to the data regardless where they are running currently. We can deploy, as I said, on edge locations, on-premise data centers, in clouds, have a combination of them, and really span this data fabric across. Then also important, especially if you're running applications with a high SLA on the platform, we provide you with all the means for high availability to replicate data, to take snapshots, etc., in the platform, to really make sure we protect the data. We also have security controls and really fine-grained policies that enable you to define user access, permissions, etc., and make sure that only the people who are allowed really also have the access to the data. And we have some intelligent data placement as well. So if you grow with the platform, we're also able to store the data efficiently in different tiers. So for example, if you want to offload part of the data after some time to an object store, we can now also integrate that. And we're still always able to find the data and know where the data is. So it's really seamless for the end user and gives you great flexibility and choice in how you build your data platform. So we organize internally the data in so-called volumes, just to give you a little bit of a teaser how we work as a platform. So the volumes are basically logical units, so you can separate them by users or by groups or by projects. So you can think of it like on the local directory, your folder structures. And then based on those volumes, we then define everything you want to control. So if you need the volume to be snapshotted, if you want to mirror it and replicate the data to another environment, base all the controls and access permissions, quotas, etc., based on those volumes. And the volume can hold all kind of data, which is files, further directories, tables, event streams, messages, etc. So you just develop this schema once and you can apply to all the data that is being stored in those volumes then. And as I said in the beginning, we want to have a look at how can you build a data platform that not just runs locally in your data center, but also spans across multiple deployments and even geographically. So just imagine those are your company locations, could be globally, could also be within a country, or just like two data centers side by side, but which are separated for disaster recovery purposes. So you have your deployments, could be cloud also, could be on-premise. And what we can do, we can connect them kind of in a transparent way to build this, what we call a global namespace or a global data fabric. So we can make it easy with a common path to the data set to give this agility and make the data independent from the underlying infrastructure. So any application that needs access to the data can navigate through that global namespace and find the data you make available, regardless whether one deployment is sitting here, as you can see, in the cloud or in a data center. And you obviously can change. So you can have, for example, one public cloud provider in one deployment and another maybe in another location, or you want to switch from provider A to provider B. So that's also something we can easily help you with. And again, the policies you create, they apply globally. So we give you a global data view in a single namespace. We can distribute the data processing this way, but you still have this unified security model and policy, which applies wherever you have parts of it running. We can do the global replication for data with that schema as well. So we take care of your disaster recovery plans. And also, if you have locations that are a little bit less equipped with network connections, we are also integrating capabilities to be bandwidth aware, especially if you have these global data flows going on. And this really helps you also in the journey to cloud environments, for example. So to sum this again up, this functionality helps you to enable application and data portability. So you can have, as you can see here on the left, parts of the platform running in different environments. You could span a couple of different cloud providers and then seamlessly move data from one to the other. And with our open set on APIs, we help you in having this common layer for your applications to gain access, and you're independent of any cloud-specific APIs because you can work with the open standards that we implement in the platform. And then you can also, what you see here on the right, use the technology to synchronize data globally and have it available wherever the applications you run need it. So basically, this is really enabling you to have a Kubernetes for data. So when we look at how we really integrate with those container technologies, to come really to the point of the presentation today, we have a little piece of software that's called the MapR Persistent Application Client Container. Difficult terminology, but it's really a simple piece of software that comes as a pre-built certified container image, and you would just include that in your Docker file, and once you deploy the containerized application, this piece of software just gets pulled in, and this allows the container and the application to have a secured access to the data platform. So you can also make sure that the containers authenticate against the data platform with that piece of software and help you to kind of control data access. If you move the container, if you spin up a new container with that piece of software, the application can always have the persistent data access because the data is actually outside of the container, residing in the data platform that we provide. So this helps you when you think back of those microservices deployments, which I showed earlier, the applications that might need to read some information, some files to start the work, and then pass on information in a real-time stream to another set of microservices doing another job. And then, for example, they want to persist log files again in the data platform so you can have a look at it for a later analytics, optimization, troubleshooting purposes, etc. So this is exactly how you can use that piece of software. So the containers can actually have a volume where they write to, which is outside of the container in our platform, but have this flexibility in reading data, writing data, passing it on to another microservices. And those microservices, again, themselves can pick up the work where they need to, etc. So this is really a nice way to have real-time access to the data, but being independent and still maintain this agile concept of containers spinning up and disappearing in your data centers. So the next step, we introduced what we call the data fabric for Kubernetes earlier in the year. So it's similar concept. Here we have also a small piece of software which integrates with the Kubernetes APIs. Now, if you're familiar with Kubernetes, we're using a Flex Volume Driver plugin, which helps us to achieve a similar thing. So we can now, with that plugin, make the Kubernetes hosts where the containers are running and give them access to the MapR data platform. So all the volumes that you create in the platform, you can then have accessed by the containers, the pods in the Kubernetes environment. So you, again, have the possibility to persist data for those containerized applications in another platform external to the container and Kubernetes environment, and scale the data as the containers grow independently. We take care of the high availability of the data, make sure it gets replicated, snapshotted, etc. We also integrate, again, our security based on tickets to the container, so you have this end-to-end security and authorization from those container environments, and also help you to build this multi-tenant environments if you need it. So having a look at this volume driver plugin, there are two ways you can deploy that. So we can either use it with static provisioner, that's terms coming out of the Kubernetes world, or we can use it with dynamic provisioner. And this is two different flavors which you can use. So with a static provisioner, you would previously create a volume and then just map it statically to a specific application container. Or with a dynamic provisioner, that's taking it a step further, where you just say, I need a piece of storage, but at the moment where you deploy the application, that's when it dynamically gets provisioned. So this is also coming more into the thinking and idea of having this very agile environment. But there are use cases for each of them. So for example, here for static provisioning, if you have, for example, a Postgres container, you're thinking of a persistent storage volume. So you pre-create the volume because you know you need it, and then the plugin would just mount that external volume to your Postgres container, and you can write data, etc. The other use case for the dynamically provisioned volumes is kind of this environment where you might think of testing a new container, and just at the moment when you spin up the container, you want to have the platform taking care of creating the volume and then just mapping it. So both use cases are pretty valuable to your environments depending on the use case. And this really helps you, as I said, to kind of have an external data platform taking care of all the data persistence, but still having this agility to spin up your container environments and gain access in a controlled and secured way to the data sets. So the consequences of using that technology is that the installation of this plugin is on a whole Kubernetes level operation. So this means you don't need to take care of each node. You just deploy the plugin against the Kubernetes API, and then it gets basically deployed and installed in the whole environment. So the use of the plugin is then also an overlay operation. That means you can just define what you need inside of those YAML files you're using to describe your application containers and pods in Kubernetes. And then the Kubernetes platform takes care and creates the corresponding volumes in the platform. So again, you can share storage and compute or isolate and scale independently as you need it. And state is no longer a dirty word then for Kubernetes. So you can really also think of deploying stateful applications like databases in a containerized environment this way. To summarize the whole story here, why did we talk about containers in Kubernetes without limits? Looking at containers, Docker, for example, they give you this application agility. So you can develop the applications and build and run them anywhere. That's the idea behind containers. But we had the challenge of how can you orchestrate the containers and have kind of tools that help you with the networking, the logging, the monitoring part, and having really this compute agility where you don't care about which host to deploy, but have someone taking care of that from an orchestration perspective. And this is where Kubernetes helps you with. So in addition to the application agility, you gain this compute agility across different deployments and host environments. And what we as MapR can help you with as a third layer here is also giving you this data agility by making it transparently where you actually run physically and store data in infrastructures, whether on-premise data centers, cloud, edge, etc., and helping you in then giving the applications access to that data. In the world of containers in Kubernetes, through that Kubernetes volume plugin, for example, in case you're running containers without Kubernetes, we have the software plugin available there as well, which you can just start within the containers and they get the controlled and secured access. And also this is not limited, as I said initially, to container environments. You can also use the platform to run other use cases on it, for example, enterprise applications, advanced analytics, Spark jobs, for example, or you're looking at maybe AI, machine learning applications. So you have probably a lot of different teams that need access to data. And we can really be this single source of truth and view on the data across all the different infrastructures. And this is really where bringing the value in having a multiple ways of serving your different teams, but still have one platform and one concept of security, data access, etc., to help you ease the administration in your organization and make sure you can control data access and still be flexible enough to handle the different new teams and use cases that emerge almost on a daily basis here. If you want to read a little bit more around that topic, we just released a new O'Reilly book, AI and Analytics in Production. It's written by Ted Dunning and Alan Friedman. This book actually talks about AI and analytics use cases, the new container and Kubernetes technologies to get the applications into production. So it's really a good book, a good read, and you can download that via our website. I put in the link here for your convenience. And with that, I hand back to Mark, and let's open up for questions.
Excellent. Thank you very much, Antje. As ever, very informative. We'll let your voice have a rest for a few minutes after that sterling effort. At the moment, there's no questions in there. If anybody would like to pop them in, please do so. We've got a few minutes. We're more than happy to look at anything you've got on your mind. Or as I mentioned, if you've got specific use cases that you'd like to look at offline, again, my details are there. Please give me drop me a line, and I'll make sure I hook you up with the relevant people at MapR and internally here. Just while questions are coming in, we've also got a couple of free events coming up that could be very interesting. We have a cognitive services and developing in AI in Azure at Thames Valley Park, Microsoft's head office in the UK, on the 6th of November. And we've also got two events, one in Manchester, one in London, about real-world DevOps, Manchester 27th of November and London 29th of November. So if you'd like information on those, again, please let me know. They're also on our website. I'd be more than happy to pass that to you, and be great to see you at those events. Tony, is there anything else you would like to add?
Yeah, I've just popped in a link in the chat window for people. So if you want to go to the containers and Kubernetes section on our website, then check it out. It will take you to links on relevant use cases and customers that are using that technology. If you want to try MapR, we've got various sandboxes available which you can download again straight from the website and test it out. Our training section is mapr.com/training, but there are 3 segments of courses, and the first one is what we call essentials, which are 10 on-demand mini courses. So they're between 25 to 40 minutes each. And they're really going to talk you through a bit more in detail about MapR, the technology, how we differ to other big data technologies. So kind of good self-paced stuff. And if you do have any questions, then don't be shy, fire us an email. Always happy to kind of get on the phone if you want to have a one-on-one conversation, talk about how we can apply this to any business or IT challenges you're experiencing in your business, then do reach out to us. We've got a very experienced team in the European market and in the UK. So yeah, happy to engage.
Fantastic. Antje, any closing words from you? There's no questions there. So I guess that means you've done an exceptional job and covered everything that was burning on people's minds.
Thanks, Mark. So yeah, just to add to Tony, if you have more questions or you want to have a look at use cases, how other customers are implementing that, please reach out to us or check our website or go to you at Grey Matter. And we're all here to help you and get your journey started into the container world.
Fantastic. Well, thank you everybody for attending. Get in touch with us. We'll be very excited to understand what you're up to, your use cases and everything else. And yep, just help us be involved. We're more than happy to do so and look forward to speaking to you. Antje and Tony, thank you again very much for your time, and everybody have a wonderful afternoon. Thank you very much.
Thanks, everyone.